You're going to witness a lot of mind-boggling concepts during this learning.
In our live sessions, we will make framework of knowledge which will give our students eye-opener results after each session.
Welcome to Tutorac's live session.
Is designed by IIT.
This is for the first time that our platform is live for the class 10 students. And I, Dhanshri Mone, your chemistry expert, welcomes you to this live session. So now let me just have a look at how many students have joined. And so today, okay, Aditya is there. Yes, Aditya, we have started the session. Akram, hi, good evening. Okay, more students to go. So till that, let me take you to our platform, that is Tutorac. So Tutorac is all about the cinematic courses produced for class 11th, 12th students and for the JEE NEET aspirants. So I think you guys like movies, right? अब सोचो अगर आपकी पढ़ाई को हम किसी मूवी के तरह दिखाएं, so what will happen? It will be mind-boggling, right? तो सोचो हम कितने अच्छे तरीके से हम अपने पढ़ाई को enjoy कर सकते हैं, right? So let me take you to our website, that is www.tutorac.com. So here you can see the courses which we have produced. So all the subjects are covered: physics, chemistry, biology, and also some other courses are also there. So you can visit there and have a look on the courses which are produced in a cinematic way. Now let's have a look. Okay, who else is there? Sheikh, Asghar, hello. Okay, more to go. So one thing I would tell you that quickly sign up on the Tutorac website to get 30 days of free subscription, and there you can access all the courses in an unlimited way and enjoy the cinematic beauty of our courses produced. And trust me, you will be able to understand the most difficult topic in an easier way. Right, okay. Coming back to the crash course on carbon and its compounds. I know very well कि सारे बच्चे जो भी 10th में हैं, 12th में हैं, they are preparing for their board exams, right? So let me brief you about the chapter carbon and its compounds. So here what you are going to study is about carbon, their compounds, and also some of the important terms like catenation, tetravalency, alkanes, alkenes, alkynes, and all these things. Now guys, one thing I would like to tell you here is that ये जो chapter है carbon and its compounds, it is the base of organic chemistry. अगर आप यहाँ पर master कर लेते हो इस course को, इस chapter को, then it will be very much easier for you to study in class 11th. Because in 11th and 12th, you will be having a separate book of chemistry and you will be studying three different branches of chemistry, that is physical, organic and inorganic. So you study the compounds of carbon in organic chemistry. Okay, so now it's time to start with the chapter. So here we have. Now imagine a situation that you are going to school. So what you will do? First you will put on your uniform, right? Then pack your bag, take your tiffin, and then you will go to school. अब आप घर से निकले हो स्कूल पहुंचते तक, you will see many things surrounding you. रोड दिख रहा है, trees दिख रहे हैं, plants दिख रहा है, गाड़ियाँ दिख रही है, everything you will see. But just imagine that one thing is common in all these substances, and that is none other than carbon. Yes, carbon is such an important element. Can you tell me where carbon is found? Is carbon present in this atmosphere or in the Earth's crust? Can you see carbon? So let me tell you that carbon is present in the Earth's crust with a percentage of 0.02, and that too in the form of minerals, carbonates, hydrogen carbonates, coal and petroleum. And in the air, that is atmosphere, it is present with a percentage of 0.03. So now let's have a look where this carbon belongs in the periodic table. So you might have seen that big periodic table जहाँ पर बहुत सारे elements रखे हुए रहते हैं, and you might think इतने सारे elements, how will you remember each of them and what you have to do? But see, सब elements का कुछ न कुछ importance है हमारी life में, and that's why we have to study those elements, and that's why chemistry is important. You can relate physics with your daily life. You can see that गाड़ी चल रही है, you can imagine what is velocity, what is acceleration, everything. But how to imagine chemistry? So chemistry is actually within us. हमारे अंदर बहुत सारी chemical reactions हो रही हैं, जिसकी वजह से you are able to breathe, you are able to digest your food and everything you can do. So now without wasting the time, let's dive into the core of this chapter. So carbon, it belongs to 14th group in the periodic table and its symbol is C with atomic number 6 and electronic configuration 2, 4. That means 2 electrons are present in the innermost shell and 4 electrons are present at the outermost shell. That means it exhibits a valency of 4, and that is why it is also known to be tetravalent. And this is the most important property of carbon, that is possesses tetravalency. That means it can combine with 4 different monovalent atoms at one time. Now, moving towards bonding in carbon, you can come across various kinds of carbon compounds surrounding you. The clothes you wear, the food you eat, everything consists of carbon. But the thing is, इतने सारे carbon compounds बने तो बने कैसे? What kind of attraction is present between the atoms? Like we are bonded to our parents, friends, colleagues, so some kind of attraction is there. Similarly, in case of atoms also, that chemical force of attraction is termed as a bond. You might have studied a little bit about bonds, right? So now moving towards bonding in carbon. So what happens is, whenever a bond is formed, an atom can either lose electrons or gain electrons, or it can share. So now in case of carbon, see, everyone in this universe is moving towards stability. In the same way, atoms also want to be stable, but their stability lies in the completion of their octet. That means they should have 8 electrons in their outermost shell. So just now we read that carbon is having 4 electrons in their outermost shell. So what it will do? Either it will lose 4 electrons and will become C4 plus cation, or it can gain 4 electrons to become C4 minus anion. But both the conditions are not possible, as a huge amount of energy is required to gain and lose the electrons. So carbon finds a midway, that it shares its electrons with the other atoms to complete its octet, and such a bond which is formed by the sharing of electrons is known as a covalent bond. Okay. Now let's have a look on some examples where a covalent bond is formed. So first of all, let's take the simplest example, that is formation of hydrogen, that is H2. So hydrogen, it has an atomic number 1 and electronic configuration 1. That means it has 1 electron in its first shell. And can you guys tell me how many electrons are present in the first shell of any atom? Just tell me in the comment box if you know. quickly reply so that I can see and go ahead further. So, you might know that there are 2 electrons present in the first shell. So, here in case of hydrogen, it needs one more electron to complete its duplet. So, what it will do is, it is having one electron and it is combining with another hydrogen which is also having one electron. So, they share their electron with each other so that they complete their duplet. And as a result of sharing of electrons, hydrogen, single bond hydrogen is formed. So, a single covalent bond is formed by the sharing of 2 electrons. Now, let us take another example of oxygen. So, the atomic number of oxygen is 8 and the electronic configuration is 2, 6. That means oxygen has 6 electrons in its outermost shell. So, how many electrons it need to complete its octet? That is 2. So, it combines with another oxygen which is having 6 electrons in its outermost shell, and they both share the electron and oxygen, double bond oxygen is formed. So, here the covalent bond is formed by sharing of 4 electrons, hence a double covalent bond is formed. Now, we have seen hydrogen, oxygen. Now, the important thing which is vital for the existence of human life or any living being is air, right? So, air is a mixture of oxygen, hydrogen, nitrogen, CO2 and many other gases. So, till now we studied about hydrogen, oxygen. Now, let us have a look on another gas, that is nitrogen. So, nitrogen, its electronic configuration is 2, 5, right. That means in the outermost shell of nitrogen there are 5 electrons. So, it combines with another nitrogen atom and share its electron with another nitrogen, and as a result of which nitrogen triple bond nitrogen is formed, and hence N2 molecule exists. So, here the bond is formed by sharing of 6 electrons, hence a triple covalent bond is formed. Okay, now let me have a look on any other doubt you are having. Okay, ma'am, please explain 11th chemistry. Yeah, sure, I will do, and I will arrange another live session for you. Okay, now moving towards another vital element which is required for the existence of living beings, that is water. You guys know that we cannot live without air and water. So, now let us have a look how water is formed, and the chemical formula of water is H2O. That means it is a combination of hydrogen and oxygen, right. So, hydrogen, its atomic number we know 1 and electronic configuration is also 1. Similarly, oxygen, its electronic configuration is 6. So, here you can see that oxygen will share its 1 electron with 1 hydrogen and another electron with another hydrogen, means as a result of which H2O is formed. Okay. Now, this was all about the covalent compounds, that means the compounds which contain covalent bonds. Alright. Now, let us have a look on what are the properties of these covalent compounds. Now, since the electron is formed by mutual sharing of electrons, hence there will exist a weak intramolecular forces within the molecule. Intermolecular forces within the molecule will be very weak as the electrons are only shared, not transferred to other element. Now, similarly, due to weak intermolecular forces, they will have low melting and boiling points. And the most important property, that covalent compounds are poor conductors of electricity and heat. Okay. So this was all about the covalent compounds, or we can say bonding in carbon. So till now you might have understood that how covalent bond is formed. Now I am saying that we are studying about the chapter carbon and its compounds, and just now I said that everywhere carbon exists. But there is a certain property of an element that it can exist in different forms in nature, and that tendency or that property is known as allotropy, right. So the substances which exist in different forms are known as allotropes. So here we are going to study another interesting aspect, that is allotropes of carbon. So let me tell you, there are basically 2-3 allotropes of carbon, but apart from that carbon exists in many forms, and the one important form is in the jewelry which you wear, that is diamond, and you might need a pencil to draw the sketches. So in that lid of the pencils graphite is present. So these are the main important allotropes of carbon, that is diamond and graphite, right. Now moving towards the properties of diamond and graphite. So first of all, that is nature of bonding, right. So in case of a diamond, one carbon is bonded to 4 other carbon atoms. So you can see here the structure of diamond. You can see here that one carbon is bonded to 4 other carbon atoms. While in case of graphite, one carbon is bonded to 3 other carbon atoms, giving it a layered structure. And due to this layered structure of graphite, it is smooth and slippery, and that is the reason why graphite is used in the lead of the pencils. Vice versa, as compared to diamond, diamond due to its rigid 3-dimensional structure is the hardest substance known, and it is a bad conductor of electricity, while graphite is a good conductor. And you all know very well the uses of diamond and graphite. Okay, so we have some comments. Okay, thank you. Why are covalent compounds generally poor conductors of electricity? Just now I told you, Rajdeep, that covalent compounds have very weak intermolecular forces. So that is why those are poor conductors of heat and electricity. And since there are no ions present in that, remember one thing, whenever a compound or a substance conducts electricity, presence of ions is necessary. I hope you might get the answer. Now moving towards another interesting allotrope of carbon, that is fullerene. So fullerene is the allotrope of carbon in which 60 carbon atoms are bonded to each other. So you can see here in the figure that it is arranged in the shape of a football, and it was designed by the US architect Buckminster Fuller. So it is sometimes also known as Buckminster Fullerene, or it is also known as buckyball. Okay. Now moving towards the versatile nature of carbon, that means why carbon forms a large variety of compounds. So first versatile nature, I told you that it possesses tetravalency, that means it can form 4 bonds. Now let us have a look on another versatile nature of carbon. So first one is the ability to form bonds with other atoms of carbon, giving rise to large molecules, and this property is known as catenation. Yes, catenation is a very important property which says that it is a self-linking property. That means carbon can combine with carbon itself and form a long chain. Okay. And the next property is that carbon can form bonds with other atoms like hydrogen, oxygen, nitrogen, and form multiple type of compounds. Now, whenever carbon is forming a bond with other atom, the bond form will be strongest and the molecules will be much more stable. Okay. Now, moving towards another interesting topic, that is hydrocarbons. Now, let's focus on this. Hydrocarbons means what? By the name, what comes in your mind? That is the compounds which are made only from carbon and hydrogen. So, those compounds are known as hydrocarbons. So, hydrocarbons basically are classified in two types, that is saturated hydrocarbons and the other one is unsaturated hydrocarbons. Okay. So, saturated hydrocarbons are the one which contains only single bond, while unsaturated hydrocarbons are the one which contains double and triple bonds. Now, moving towards their nomenclature. Nomenclature means naming, they have a specific name. So, let us begin with alkane. So, alkanes are the saturated hydrocarbons. I told you that saturated hydrocarbons are the one which consists of only single bond, while alkene and alkyne, they belong to category of unsaturated hydrocarbons, where alkene are the compounds which consist of carbon-carbon double bond, while alkynes are the one which consist of carbon-carbon triple bond. And when we have to derive various compounds formed, we need a general formula. So, for alkanes, the formula is CnH2n plus 2, for alkenes it is CnH2n, and for alkynes it is CnH2n minus 2. Now, remember these formula so that you can derive many of the hydrocarbons belonging to alkanes, alkenes and alkynes. Okay, let me have a look on the comments. Ma'am, can we have one session on balancing the chemical reactions too, please? Yeah, sure, why not? Okay. So, what is single bond? So, to understand what is single bond, you have to go a little bit back. Okay, just now I told what are single bonds. So, let me brief you that single bond is the bond which is formed by sharing of two electrons. Okay. So, now moving ahead with the alkanes. So, alkanes are the compounds which have the general formula CnH2n plus 2. So, now what is N there? So, N denotes the number of carbon atoms. So, by putting the value of N, we can find out the formula for the compound. Okay. So, now if we put the value of N as 1, so we get the formula as CH4. That means the carbon is bonded to 4 hydrogen atoms with a single bond. Now, when the value of N is 1, we give the name meth and add a suffix "ane" as it belongs to the category of alkanes, right. Similarly, when the value of N is 2, so we write the name as "eth" and add a suffix "ane." So, the name comes out to be ethane and the formula is C2H6. That means one carbon-carbon single bond is present and the remaining 3 bonds are bonded to hydrogen atoms. Okay. Now, if the value of N is 3, the formula comes out to be C3H8, and for compounds having 3 carbons, we write the name as prop and add the suffix "ane" and the name comes out to be propane. So, let me draw here the structure for you. So, 3 carbon atoms are there bonded by single bonds, and at the remaining bonds we will add hydrogen. Okay. So, these are the different types of alkanes. Now, in the similar way, if you put the value of N as 4, 5 and 6, you can write the name as butane, pentane, hexane, and you get the formula and structure for the respective number of carbon atoms. So, these were the series of alkanes. Okay. Now, moving towards alkene. So, alkenes are the compounds which consist of double bond. Okay. Here the formula is CnH2n. So, now let us put the value of N as 2. Now, one question comes here, why we cannot put the value of N as 1? So, now since alkenes are the compound which consist of minimum one carbon-carbon double bond, right. So, if one carbon is there, so with whom carbon will form a double bond? So, that is why this is not possible and we start the chain with N equals to 2. Okay. So, as I told you that when the value of N is 2, means if 2 carbon atoms are there, we write the name as eth, and now we are studying about alkenes. So, we add the suffix -ene and the name comes out to be ethene, and we get the formula as C2H4. Now, let me draw the structure that one carbon double bond carbon is there. So, now carbon has 2 more bonds to form. So, it will form bonds with hydrogen atoms, and this is the structure of ethene. Now, if the value of N is 3, the formula comes out to be C3H6, and when N equals to 3, we write the name as prop and we will add a suffix -ene as it is an alkene. So, we get the name as propene and the formula is C double bond C single bond C, and hydrogen atoms will be bonded to the carbon atoms. So, this carbon has formed 3 bonds. So, it will form one more bond with hydrogen, and this carbon will form 3 bonds with 3 hydrogen atoms. Okay. So, this is the structure of propene. Now, moving towards the last category, that is alkynes. So, alkynes are the one which consist of carbon-carbon triple bond. Okay. So, now the formula for alkyne is CnH2n minus 2. You remember it in series. For alkanes, it is CnH2n plus 2. For alkenes, it is CnH2n, and for alkynes, it is CnH2n minus 2. I know that many comments are coming, doubts are coming. So, guys, wait for a while, I will get back to you in the comments, okay? Okay, let me finish this. So, when the value of N is 2, the formula will be C2H2, name will be eth, and now we will add the suffix -ine, that is ethine. Okay. So, here carbon-carbon triple bond is present. Now, since carbon has completed its 3 bonds, means 3 electrons it has shared, now it has 1 more electron to share. So, it will form 1 hydrogen, it will form a bond with 1 hydrogen. Okay. Now, if the value of N is 3, the formula we get is C3H4 and the name will be propyne. Now, we have to add the suffix -ine in case of alkynes. Okay. So, here we need 3 carbon atoms. So, 1 triple bond should be present between 2 carbon atoms. So, it is present, I have made. Now, this carbon is having 1 valency left. So, it will form a bond with hydrogen atom. Okay. This carbon's tetravalency is completed, and with the last carbon it has more 3 bonds to form. So, it will combine with hydrogen. So, this is the structure of propyne. So, this was all about the saturated and unsaturated hydrocarbons, alkanes, alkenes and alkynes, in which single carbon-carbon single bond, carbon-carbon double bond and carbon-carbon triple bonds are present respectively. Now, there is another category of hydrocarbons where atoms are present in cyclic thing. So, those are known as closed chain structures. Okay. Now, let us see some of the examples, that is cyclohexane. So, you can think that ene is there, that means it belongs to the category of alkane, right, and benzene is there, that means it belongs to the category of alkene. Okay. So, just have a look on the structures, that here since it is 6 carbon atoms are present, so it has formed a hexagon, right, and the remaining bonds are connected to hydrogen atoms. Now, in case of benzene, again we have 6 carbon atoms, and these carbon atoms are bonded to one hydrogen atom each with the presence of alternate double and single bonds present. Okay. So, we can write the structure of benzene as this also. So, this you will study in your higher classes. Okay. So, just remember this for now. Now, till now we studied about alkanes, alkenes and alkynes, right. So, our hydrocarbons part is little bit completed. Now, if we know that the formula for alkanes is CnH2n plus 2. Okay. So, what if I remove one hydrogen from methane? Okay, we know that this carbon is bonded to 4 hydrogen atoms. Now, I am replacing this hydrogen or I am removing this hydrogen. Then the remaining group, that is single bond CH3, this is known as alkyl group. Okay. So, since it is obtained from methane, we name it as methyl. In the same way, if I remove one hydrogen from methane, so its formula comes out to be C2H5. So, it is known as ethyl. If I remove it from C3H8, it will be C3H7 and the formula will be propyl. And if I remove it from C4H10, the formula becomes C4H9 and the alkyl groups become butyl. So, these are the names given to the compounds we obtain after removing one hydrogen from alkanes. Okay, just give me a minute. Ma'am, is alkane different from alkene? Yeah, just now I told you that alkane are the compounds which contains only carbon-carbon single bonds, while alkenes are the one which contains carbon-carbon double bond. Okay, my dear, the spelling is ALKENE for alkene and ALKANE for alkane. Okay, I hope your doubt is cleared. Some decay is there. Okay. Ma'am, is there any chemical test to distinguish between saturated and unsaturated hydrocarbons? Yes, so many tests are there by which you can differentiate between saturated and unsaturated hydrocarbons, and these tests you are going to do in your 11th and 12th standards definitely. Okay. Now, moving towards another thing, that is, just now I told you about the alkyl groups. That means, if I remove one hydrogen from methane, I will get CH3. That means, one valency of carbon is empty. That means, at that point, some group can attach to that carbon. Now, if I bond this carbon with one group which is OH, so the formula becomes CH3OH. So, now what is this OH here? So, OH is a group which when attached to this alkyl group changes its properties. We know that methane is a gas, but when OH is bonded to that methyl, the compound is not now methane, it is methanol. I am writing here the name, it is methanol. That means it belongs to the category of alcohol. Now similarly, I told you there about ethyl group, which is C2H5. In the same way, if I add OH to this C2H5, the formula becomes C2H5OH and it is named as ethanol. Okay. So, these are the groups which when added to any other carbon chain changes the properties of that particular compound, and these groups are known as functional groups. That means the property of the compounds will depend on this particular functional group. Okay. Now, moving towards another category, that is of halides. Have you ever heard the term halogens, or are you aware about chlorine, bromine, iodine? Okay. So, the 17th group elements are known as halides. Okay. So, now if I add one chlorine here, okay, that means in place of hydrogen one chlorine is there. So, I get CH3Cl and the compound is known as methyl chloride, or it is also known as chloromethane. See, whenever we name the organic compounds, we name it according to the IUPAC nomenclature, about which you will study in your next higher classes. Okay. So, for now I am telling you both the IUPAC nomenclature and the common name also. So, CH3Cl is commonly known as methyl chloride, while in IUPAC it is known as chloromethane. Now, similarly, if I add chlorine with ethyl, if I combine them, then the formula comes out to be C2H5Cl and the name is ethyl chloride, and according to IUPAC it is named as chloroethane. Okay. Now, in the similar way, you can add bromine, iodine, fluorine in place of chlorine, right. Now, suppose if I write CH3Br, then it is known as bromomethane, or in the common name it is known as methyl bromide. So, this is how you name the carbon compounds according to IUPAC and the common names which we know. Okay. Now, moving towards some of the functional groups which you should know and will be helpful for your 11th classes. Okay. So, basically we have halides, which just now I told you, that is chlorine, bromine or iodine. So, for that we name it as halo, and we use the name, right, like chloromethane, bromomethane, chloroethane, like this. And the formula for functional group is chlorine, bromine, iodine, etc. Okay. Now, coming to alcohol. So, the functional group is OH, and to name an alcohol we add a suffix OL. Then we have aldehyde. So, CHO is the functional group, and while naming them we add a suffix AL. Okay. Similarly, for ketones we use a suffix -one. Okay. So, in the chat section girls are also there. तो I know that सभी girls को पसंद है nail polish लगाना, right? But जब nail polish मिटाने की बारी आती है, so you use some solution, right? So that solution is made of some ketone. Okay. तो उस nail polish remover में कौन सा ketone present है, that you will tell me in the comment section. Okay. Now, moving towards another acid group, that is carboxylic acid, and the functional group for carboxylic acid is COOH, and we write the name by adding a suffix, that is oic acid. Okay. So, let me take a while to read these comment section. Ma'am, does alkanes have any pi bonds? My dear, pi bonds consist only of double and triple bonds. Where single bond is present, it is only a sigma bond. Okay. And ma'am, what if we have double bond present in alcohols? See, many functional groups can be present in the same compound, but what name you will give, it depends on the other functional group which is present. And if a double bond is present in case of alcohol, let us say for example, we have carbon double bond carbon, and then again one carbon is present and OH is there. Okay. That means we have to name it accordingly. That means it is also an alkene and it consists of a functional group, that is OH. So, about this nomenclature you will study in your 11th standard. Okay. So, I am not covering it here as it is not in your syllabus for now. Okay. Now, moving towards another topic, that is homologous series. Okay. So, this is something important which can come in your exams. So, now homologous series are basically the series which have same general formula, same functional group and similar chemical properties. Okay. Just now we studied about alkanes, alkenes and alkynes. So, particularly for alkanes, we wrote so many number of compounds starting with methane, propane, ethane, everyone, right. So, when you increase the number of carbon atoms, you get the whole family. Now, what happens is, see, in case of alkanes, now we have methane, ethane, propane and butane. So, for methane, the formula is CH4 and its molecular mass is 16. I hope you guys know how to calculate a molecular mass, right. Now, coming to ethane, the formula is C2H6 and again here the molecular mass is 30 for ethane. So, what difference do you see here in methane and ethane? See, both are alkanes, that means the functional group is same for both the compounds. So, what is the difference here? So, the difference is between the number of carbon and hydrogen atoms and the molecular mass. That means the carbon atoms or the formula differ by one CH2 group and mass by 14 units. In a similar fashion, coming to propane and butane, the formula for propane is C3H8 and mass is 44, while in case of butane the formula is C4H10 and the mass is 58. So, again you can see here that propane and butane differ by 1 carbon and 2 hydrogen and their molecular mass also differs by 14 units. So, this is about the homologous series. Okay. So, homologous series is the series of compounds in which same functional group is present, right, and the consecutive members differ by one CH2 group and mass by 14 units. Okay, too many are there. Can we use that nail polish remover to feel cold on your hands during summer? It's a chemical, so you can't use it whenever you want, okay. Ma'am, the answer for your question on nail polish remover is acetone, also known as propanone. Yeah, exactly, correct. Okay. Now, coming to the homologous series, right. So, just now we saw that homologous series are the one where functional group will be same and the members will differ by one CH2 group and mass of 14 units. Now let us see what are the characteristics of homologous series. I have already told you, but just let me brief you with the properties. So homologous series are the one which will have same general formula, same functional group as we saw in case of alkanes. Then physical properties will be similar like melting point, boiling points, density. So they will show a gradual change when we move to the higher members. Okay. And similar chemical properties also, and the same thing, that is they will differ by one CH2 group and molecular mass by 14 units. So let us take one more example for homologous series, and that is of alcohol. Okay. So we have taken here methyl alcohol, ethyl alcohol, propyl and butyl alcohol. Okay. So in case of methyl alcohol, which is also known as methanol, the formula is CH3OH. In case of ethyl alcohol, it is also known as ethanol, that is C2H5OH. So here also the difference is they differ by one carbon atom and two hydrogen atoms. And if you calculate the molecular mass, here also the difference will be of 14 units. Okay. Now coming to another example, that is of propyl alcohol and butyl alcohol. So here also the difference will be of CH2 group and mass of 14 units. So this was all about the homologous series. Okay. So we are at the end of this chapter. We have covered all the things like starting from the versatile nature of carbon, its tetravalency, catenation, how bonding takes place in carbon compounds, right. Then hydrocarbons, then their classification like saturated, unsaturated, where we studied about alkanes, alkenes and alkynes. So alkanes are the one which consist of carbon-carbon single bond, alkenes are the one which consist of carbon-carbon double bond, and alkynes are the one which consist of carbon-carbon triple bond. And this was all about the homologous series which we studied. So this chapter is basically very important for your higher studies also. Okay. So I hope I was able to clarify your doubts and make your concept clear. And if you want any other doubt session or any other concept to revise so that you can prepare for your board exams, so just let me know in the comment box so that we can arrange another live session for you. Okay. And for the schedule of live sessions, just follow our Instagram and Facebook pages. Till that, stay tuned with Tutorac.